Part of the periodic table lies a set of elements called transition metals. Transition metals are very close to me. My graduate work had a lot to do with transition metals, and my group at University of Virginia now is doing research using transition metals to do organic reactions with. Now, what characterizes transition metals, we can talk about these in several different contexts, but from an electronic standpoint, the reason they show up in this part of the periodic table is, of course, their electron configurations. And what characterizes all transition metals is that they all involve half or partially filled d orbitals in their valence shell. Now, sometimes the very last row of the, or column rather, of the transition metals, zinc, cadmium, and mercury, these are also sometimes lumped into the transition metals, but technically they actually are not transition metals in that these guys have filled D shells. But all of the rest of these guys shown up in orange here, you'll recall, have partially filled D shells, and that gives some of their chemical properties, which we'll talk a lot more about in a moment. Okay, so some basic characterization, let's go ahead and keep this here. Some basic properties of the transition metals. These are, again, all metals in that they have valence electrons that are delocalized. These are typically harder elements in their elemental form, harder metals than the metals associated with the main group elements. They're higher melting. Tungsten, for instance, is what's used in light bulbs. Very, very high melting, 3,000 degrees, very, very high melting metal. These materials, when they make compounds, are very often colored. And that's one of the attractive features of working with these things from my standpoint. Just beautiful colors of compounds. And we'll talk a lot more about where that color comes from and why it's so particular to transition metals. What types of electronic transitions give rise to these colors that you can have in transition metals that you don't have necessarily with the main group elements. So we'll have a lot more to say about that. Likewise, the magnetic properties are really interesting for these compounds. And again, these have to do with these half-filled, or I keep saying half-filled, but these partially filled d orbitals. So once again, we'll talk about magnetic properties as well as the optical properties, or the colors that come from these things. So let's talk a little bit more about just kind of the periodicity, if you will, of the transition metals and how that compares to the main group. We know about the trends in the periodic table as far as size, as far as ionization energy, and so forth. What about within the transition metals? Well, one thing that we see that's different is that if you look at the size of the elements, remember the general trend in the periodic table is as we go from top to bottom in the periodic table, the size increases. Well, not so, as it turns out, for transition metals, especially if we compare the second and the third rows here. These guys have actually identical sizes almost absolutely identical, not, within error at least. And this is a phenomenon referred to as lanthanide. Mindbites.